All right, so last time we were talking about creating classes, and basically we mentioned that there are three types of class qualifiers: public, private, and protected. Qualifiers basically are descriptors of a class. If a class is public, then basically everybody gets to access the properties of the class. Properties being methods and data members. Okay? So, if they are private, then essentially only the class can look at its properties and methods. But if it's protected, it's someplace in the middle. And we'll talk about specifically what that in the middle means. Okay, so let's take a look at, we're going to create a class in class. We're going to look at how we create a class that's going to be useful for us. The class is going to be called the rational class. And basically the rational class is just like a fraction with an integer numerator and an integer denominator. Okay, easy enough. So we are going to create this class so that we allow access to the object, construction of the object, overloads for some operators, specifically plus, minus, and star. And we also want to be able to read and display objects of type rational. Okay, so what we're going to look at here is we're going to look at, this is the header file. So this is the header file for the rational class. So how does this look like? So first of all, a couple of things here. Everybody understand how to include IO stream. That's going to basically open up the IO library so that we can use it. Using namespace. Namespace is a keyword. And basically when we say using namespace STD, that means standard namespace. And that means that objects and classes are defined within a namespace. And STD is the standard namespace. So basically when you say that, you're basically giving yourself access to objects that are defined within that scope. I'll talk a little bit more specifically what a namespace is, but for now, just have using namespace STD in there, and everything will be fine. Until it's not, and then you have to know something more about it. All right, so to declare a class, basically we write the keyword class, we give it a name, we open a bracket, we close the bracket, we put a semicolon. Everything in here is gravy. Okay, it's all optional stuff. We don't have to have that in, but of course we want to have some stuff in there. So got to have the class keyword, identifier, bracket, bracket, semicolon. Now, inside the class I have a public label and I have a private label. Once I label something inside of a class, everything that follows it is public until it's not. When a private label is encountered, then everything that follows that is going to be private. So notice I'm using public, private. I am not using protected. There's no need for it right now. Now, if I were to say public, then I went private, it would switch to private. But I can go public, fine. And then so I can interchange them. When I write it, whatever follows it is that qualifier until I change the qualifier. Now, if I get rid of the qualifier public and I get rid of the qualifier private, everything goes to the default qualifier of a class. And that is private. Private. Okay? So by default, the qualifier without any labels is private. That was a good guess you made, though. Now, there is another keyword in C++ that's a throwback to C. But it was enhanced as a part of C++, and that keyword is called struct, struct, struct. So for example, I can do everything I did with the word class. I can say struct, rational, close, semicolon. Everything would be exactly the same. Struct and class is the same. Struct stands for structure. It was the original C way of putting together a bunch of different properties before methods existed as part of a class. But when they went to C++, they said, hey, we're going to allow structs not only to have data properties, but we're also going to have method properties, okay? So, now, what's the difference between a class and a struct? Actually, nobody uses struct, but you'll still see it when you go to legacy code. When you see other people's code, you'll see the keyword struct. Here's what's important to remember. If I had struct here instead of class, and I got rid of all my qualifiers, then everything inside the struct would be public. So struct, all members are public by default. Class, all members are private by default. And of course, we just use these to make it clear. If I really wanted to, I could put, for example, get rid of this, stick these guys on top with nothing, and then say public, and that would work too, but it's a little confusing. You can see how beautifully clear it is here. This is public stuff, this is private stuff, everybody's happy. All right, let's talk about these, the code here. So basically the class is called rational. So notice that I have, following the public label, I have rational, 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 rational. There are 4 methods, because I see parentheses, 4 methods that are marked rational. Those methods, notice, have the same name as the class, therefore they are referred to as class constructors. What are constructors? Constructors are methods to build objects. Classes are templates, they're types, and then when we instantiate them, we build objects out of them. Okay? So, why do we need multiple constructors, and what are these constructors? So, we have multiple constructors to allow us to build rational objects in a variety of ways. For example, if I have no information, but I want a rational object, I can use what is called the default constructor. I have no information, but I want a rational object. If I have an int parameter and I want a rational object, then I would like to construct a rational with a single int. That's an int constructor. Notice that this constructor has how many properties? Parameters? 2. They're both int. So if I have 2 int values and I would like a rational, here I go. Then I'm going to create this one like this. And the last one, you're going to learn a lot more later, but I'm just going to give you a brief idea what it is. So again, it's a constructor because the name matches the class name. Now the parameter inside this constructor is rational, which is the same as the class. It's also by reference, and it's also a const, which means constant. Okay, so when you have a constructor where the type of the parameter, where the type of the single parameter is a const, same type as the class by reference, that's referred to as a copy constructor. C-O-P-Y, copy constructor. Now, you might say, what the heck is a copy constructor? Well, it's a copy constructor. It basically says the input coming in is one of the rational objects, and I'm going to construct another rational object. So it basically copies what the parameter is. Okay, basically that's what it is. Now, sometimes you know when you're using a copy constructor. Other times, a copy constructor is being used whether you know it or not. So that's important to know. There's a lot of things that go on to C++ that are kind of like hush-hush. It looks very nice and pleasant. Looks like maybe only a couple of methods. All of a sudden, you're telling me 6 methods are executing? Well, what's... Okay, so you got to know what's executing and et cetera, et cetera. All right, so these are the 4 constructors we have. Now, if I skip down to the properties, notice that I have an int and an int, top and bottom. Those are going to be my numerator, denominator of the rational object. And then I allow a method called numerator, which returns, and actually specifically going to return the top because it's an int. Okay, so numerator returns an int, denominator returns an int. Notice that constructors show no return value. So they don't return any, you don't write anything as a return value. There's no int, there's no void, there's nothing. It's just nothing. You skip the return type. Still a method, constructor method. But every other method is going to either return something or it's going to return void. So in this case, numerator and denominator both return int types, and they take how many parameters? Neither of them take any parameters. And also notice that there is a const, which is constant, keyword after the method. Now what the heck is this? Well, we know this one is a const. Basically we're saying that the incoming parameter to this constructor is a constant, which means you can't change it. But there are no parameters here. So what this is referring to the fact that the numerator method cannot change the object that's calling the method. So, for example, if I had created a rational object, so let's look at a very simple instance of this. So let's look at the example here, rational with an intent constructor. The code would look something like this. I would write rational, okay? Then I would give it a clever name like R, and then I'm going to say 3, 4. So this code will create a rational object where 3 will get set to the top, and 4 will get set to the bottom. That makes sense, right? So that would be an intent constructor, for example. So now, if I wanted to output the numerator, I could say something like Cout, and I'm going to say R dot numerator. Okay? Are you with me? So R is a rational object, and then I'm using R again, but this time R is calling this method. So the terminology that I want you to get used to is when an object, like this rational object R, is invoking a method, we typically say is invoking a method, is calling a method, is calling a function. We typically refer to the object that's calling the method as the host object. So the host object is the object that is invoking the method. So why am I talking about the host object? Because when you have a method that's being declared in the header and the const comes outside of the parameter list, it means that in the process of calling this method, we can expect that nothing will change in the host object. Now, what could change in the host object? Well, the host object R has a top and a bottom, right? Now, if that top and bottom is equal to 3 and 4 respectively, then when I say Cout R.numerator, I can be certain that when this line of code executes and I go to the next line, the value of top and bottom is still 3 and 4. They cannot change. If I didn't have the keyword const, it doesn't mean that the top and the bottom would change, but it doesn't mean that it couldn't change. So that means that the method could side effect and modify the actual properties. So this simply says that you may not, in the code of this method and this method, modify the host object. David?
So that means that const is the same as the final keyword in like other.
Exactly. So const is the same as the final keyword in Java, for example. Yep.
What happens if you put the const before int?
This one?
Const, int, numerator, parentheses, const. Or if you put the
Where am I seeing? Where are you seeing that? Here. Huh?
Next one.
Here?
Yeah. What will happen if you put the const keyword before the int?
The const keyword before?
Int, numerator, before int, like at the start of the line.
I don't think, I understand your question. I don't think you can return a constant. I don't think you can return a constant. And why I don't think so is another story, but I don't believe you can return a constant.
Because I've seen code where const comes
Before the return value? I mean, think about it. Well, I don't want to get it. We can revisit this. I'm not asking you to drop it. I want you to remember this. We'll plug it in and look at it. Actually, you're making me think about it, but I don't think so. It's possible. It's possible. It's possible, but there's a complexity in the return type is in that the return type itself could be passed by value or by reference. You follow what I'm saying? So what do you, if you're passing it by reference, what would it mean to be a constant reference? That doesn't make any sense because if it's a reference to something that exists someplace else. You can't declare it a constant if it's not a constant. So it's tricky. So, but the point is well taken. I'll think about it and I'll look at it. But there's many more things. Yeah.
Originally, object cannot be changed. What?
here. So with these keywords, then the original object, which we call the host object, cannot be changed. Okay?
Why do we have to use a const one more?
Why do we have to have this at all?
Why do we have to use a const like one more?
Here. Why do we need this?
Yes.
We don't.
You don't need.
We don't need to use it. This could be fine without it. It's just that if it's not, keep in mind, let's say you are developing a program with me and I am writing the rational class and you're writing another module, right? So I give you this header file. So when you looking at this header file, you know how to construct rational objects. And now you can read the numerator and denominator and not have to worry that when you're using the host to get the numerator or the denominator, that anything can change in there. So we're saying these methods are not allowed to change the host object. So it gives you peace of mind that the object you used to call this method is going to be unchanged. If I didn't have it, you could still use it. It could still behave the same way. It doesn't have to change the object, but it could. Well, what if it doesn't happen? What if it doesn't change the object, but next year, this guy over here, Chris, gets to the code. He starts modifying it. And now he's changing it. It's like all of a sudden your code is now behaving differently. Because there was no const, it wasn't changing the object, but then Chris modified the code. All of a sudden, he's like changing stuff. Can't trust him. Okay? All right, so now we're going to go into a few. Let's kind of skip down here. We have a read method. A read method is going to read into the top and the bottom. It's going to return nothing, so I have to say void. And then I have a display. Display is going to send it out to a stream. So it's going to have to return nothing. I don't need to return anything. Now, what is it displaying? It's displaying this. Can it see this? Yes, because your methods can see your properties. Because every method in a class can see everything in the class. Private, protected, public doesn't make any difference. Those modifiers have to do with the outside world looking at you, not at yourself. You are inside this nice shell, so you can see everything. Okay, so now that we talked about those, we have 1, 2, 3. Now these are additional operations in this class. So we have constructor methods. We have this, I will call this get methods because we're reading the numerator. You can think of this method as a read-only method. Does that make sense? Read-only? By read-only says that, well, I shouldn't even say read-only. Read-only. So basically you can only read the object but you can't change it. So this is a read-only method. It reads the properties but it can't change them. This one, read-only method. Now, these three, boom, boom, boom. These three are special. These are still operations within the class, but they are not methods in the same way we think of them. They are actually operators that are being defined or declared, if you will, as a part of this class. We are declaring operators to behave in a special way within this class. So when you see the keyword operator, 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 then what follows that is an operator. But this operator is like a method. It's going to have code. The only different thing about a method and an overloaded operator, which is what we're doing, is that the overloaded operator looks different. It doesn't look like a method. It's not called by a normal name. Its name is its symbol. So let's think about it for a second. So we're saying we have an operator equals. What's equals? Well, that's assignment. So we're saying that we have an operator called equals. And it will return nothing. And it will take as a parameter a const rational. So we'll take a parameter, which is a constant. Now, what does this constant mean here? It means you can't change this formal parameter. Okay. Now we have another operator. We have operator plus. This operator plus has another parameter, const rational, and it returns a rational. So let's think about what that actually means. And then finally we have a star, which is like multiplication, but again, you can define it to do anything you want it to do. And the star operator takes a const rational parameter and returns a rational. Now I do want to let you know that right now you can see that numerator returns what type? Int. Does it say int or int reference? It says int. Therefore, we say that this method returns an int by value. What does by value mean? By copy. It copies it. Where does it copy it? Don't worry about it for now. We'll get to that. So therefore, this is returning by value, by value. Now this one, operator plus, takes this parameter and returns a rational. By value or by reference? By value. Why? No ampersand. Same thing here. This rational return by value. So I could have by reference. What's a reference? It's a dereferenced address. I also could return pointers. So I could return, for example, instead of returning the numerator, I could return a pointer to an int, or a pointer to an int, or a pointer to a rational, or a rational star, which is the pointer to a rational. If I return a rational star, am I returning it by value or by reference? By value. Because there's no ampersand. So a pointer is still returned by value. If you want to return a pointer by reference, you have to return a rational star reference. Now you're returning a pointer by reference. So be happy that we're not doing all those things yet, but we'll get there. But right now we're trying to keep it simple. You know the KISS philosophy, right? KISS, keep it simple. Okay. So everybody knows that. So we want to keep it simple, get the basics, but there's enough stuff in here to keep us busy. All right, so everybody understands so far what we have? Generally speaking, so these are declarations. Yes. And what's your name?
Sriram.
Sriram? Sriram, okay.
What does the rational do? Is that a type or what is that?
It's a type, but it's a user. It's our defined type. We're defining this class, rational. Like I could define a class called cat. Could have a color, length of the whiskers, things like that. So this, I'm just defining rational, which is like a fraction or is like a rational object, top over bottom. Okay, yeah, good.
Why can't rational be value, which is just class?
Value.
Yeah, you said it's gonna be value type. Rational is value type.
Well, rational is a class, right?
Yeah.
So it has data properties, right? So it has top and bottom. It also has some constructors, some read-only methods. Okay, display method, read method, and some overloader operators. But your question was what?
So this rational is also like it's gonna be value, not reference or pointer.
Well, this is a class. So classes are not by pointer or reference. Classes are just types. When we have objects, then objects could be pointers to objects or references of objects. So we can't talk about references or objects here because this is just a type declaration.
Has it to be value?
Yeah, so you'll see, I'll give you some examples. Now, the last line right here is very strange because this line happens to be not inside the class, but outside the class. But since I told you this file is called what? Rational.h, which is the header file. So since this file is rational.h, this method this header is inside the header file, but it's not inside the class, it's outside the class. So let's see what's going on here. So here, this one is the most strange one. You can see that we are overriding the operator output. And the parameters are O-stream reference as well as a const rational reference. Okay, I mean just whatever. And then it returns an O-stream reference. Now I'll give you just a basic idea what this is before we actually look at it. How it's implemented. O-stream is a class. And specifically, OStream stands for output stream. What kind of output stream? Actually, any kind of output stream. It's a general output stream. Is it a file stream? No, but it could be. It could be one, okay? So it's an output stream reference. So we're returning a reference to an output stream object. We're taking as a parameter a reference to an output stream object. And the second parameter is a rational reference constant. These are just formal names. These names, actually, we could cross these away, and it doesn't make any difference because this is just a declaration. We don't really need the names. Okay, any questions before I... So now we're going to look at the CPP version of this. Now we're going to implement this thing, okay? So, again, remember, top and bottom are my properties. I also have a method normalize. Normalize is the method that says, hey, if you construct something like 6 over 8, before you know it, I'm going to make it 3 over 4. I'm going to find out the greatest common factor, and I'm going to divide top and bottom by the greatest common factor so that I keep these numbers minimum. The reason I made this method private, I don't have to, is because I don't want anybody calling it. I want, when you're constructing something, I'll call it. Before, so you give me whatever you want, and then I'll say, very nice, thank you very much, and then I'll normalize it. Without you knowing about it, without you having to do it. So the normalization will be transparent to the user. Keeps things easy that way for the user. Okay, so now we're going to go to the implementation. So this is going to be the H file, this is a CPP file. So here it is. So notice the first thing we do is we pound include our header file, rational.h, and of course we're going to pound include IOStream if that's appropriate. We're going to use the standard namespace. Okay, now let's jump right into here. Where do I want to go? I want to go in here. What is this? This is a constructor. When we implement in C++, when we implement a method in a class, we have to specify not only the method name, but also the class name. Why? Because we can have 3 different classes, and they can all have a method called display, display, display. So the display is not enough to define a method. You have to say, I'm defining a method, and it's part of this class. So that's called the class name. That's called the method name. So clearly, this is a constructor. This double dot, double colon is called a scope resolution operator. So it tells you that this method is in the scope of this class. By the way, we also use the scope resolution operator to define namespaces. So for example, now, I'll give you a little quick aside of namespaces. So let's say you have a class called rational, okay? Like we do. And our rational is like int over int. But let's say I wanted to have another rational, and I want to call it rational, but I wanted to have the top and the bottom be complex numbers. Well, clearly they're not exactly compatible with each other. So we want to separate them. So what I could do is I could put one into one namespace, the rational class into this namespace, and then have another rational class, also same name, into a different namespace. So if I wanted to differentiate between the 2 namespaces, I could have the namespace double colon class name, and that would be a scope resolution for the class within the namespace. Okay, so namespace simply allows you to overuse class names by grouping them inside of a namespace. Okay. So at any rate, so here is our rational constructor. Notice that the parameter is an int, it's numerator. So numerator is the formal parameter name into the constructor, and look what I'm going to do. Colon, notice that there's no code in this constructor, but we have a colon. A colon is a way that we can do, if we choose to write the initializing of the properties. Top is my property in this constructor. Bottom is my other property. If you choose to construct a rational with a single int, then I'll put that into the top, and I'll put 1 into the bottom. So if you say I want a new rational object with, let's say, a value of 5, I'll make it 5 over 1. If you make it 3, I'll make it 3 over 1. If you make it -5, -5 over 1. If you give me 1, I'll put it over 1. Easy? Easy. Okay, so that's it. Now, the next one we have what? What is the difference between this one and this one? This is an int-int constructor. So this one has an int and another int. Since I have a top and a bottom numerator, I'll call it n and d. So basically, colon means here's the action for the initializers. And top gets n, bottom gets d, and then I call normalize. How come I didn't have to call normalize here? Because over 1, you can't normalize it. Anything over 1 is already as simple as it can go. But if you give me 8 over 6, normalize will change those properties to 3 over 4. Notice that normalize has to be called within the body of the constructor because we're not initializing properties. So, the name of this stuff right here, when you have a constructor and you follow by a colon and then properties with initializers, this is called a member initializer list. Member initializer list. So this is a member initializer list, so is this one. But we are limited only to initializing members. We cannot do that, we cannot call method in a sense code. Notice that if we have a member initializer list, but we don't want to have any code, we still have to have the brackets for the code, where the code basically, so the code is essentially non-existent, but we do have some behavior, and that is the member initializer. Okay, now, the next constructor is what kind of constructor is it again? It's the copy constructor. So the copy constructor, how do I know that? Because the parameter is a const rational reference, which is a reference to the same type as we're constructing. So I'm passing a rational by reference, and what am I doing? I'm trying to construct a new object based on its value. So what I do is I use a member initializer list, and I set to my top the parameter numerator. Does that make sense? So the parameter numerator is a value of the parameter, but I use it to initialize my own top. So I'm copying it. I do the same thing on the bottom. I go to the parameter, I pull out the denominator, and I initialize my own bottom with it. So top and bottom are initialized. There's no need for any additional code, so the code is just empty brackets. Any questions so far? Yeah.
So we can also add like a default constructor.
Say again?
A default constructor like for the C++. The default constructor.
Yeah, I don't know why I don't have a default constructor. It should be there. Maybe I lost it on the next page. We need a default constructor because it's in a header. Is it on there?
Yeah, it's at the top. You have GCD and then rational, not zero, bottom one.
It's not this one though.
Very low.
Go higher. Or?
Right below the line you were just pointing at.
Oh.
So you have int GCD, and then right below it is your default. Up.
Is it up here?
Right at the top. Second line from the top.
Second line from, oh here.
Yeah.
Oh! Okay, so spacing matters. Yes, it's there, okay. You're right, I was like looking, yeah, so that is actually right there. So what we have here is so this is rational, constructor, class rational, member initializer. So if you give me no information, I'm going to assume you want your rational to be equal to 0. Now, maybe you don't. Maybe you want your rational to be equal to 1. I don't know. But my decision is my default behavior for my default constructor is to initialize the top to 0 and the bottom to 1. So by defining all these constructors, basically what I'm doing is I'm making sure that nothing really bad happens. Actually, what else can I do here? I might want to be very careful here and not to, see if I just say bottom D, that's a little risky. Why? Because you might have given me a 0 there, and then I'm in trouble. So I could have basically got rid of that initializer and say if D equals 0, then bottom is equal to 1, else bottom is equal to B. So I could have protected. So bad things can still happen, so it's not a perfect job. Okay, so let's look at the next one here, which is our assignment operator. Actually, let's look at the where's the star operator? Do we have that? No? Where's our star? Can you see the star operator? Oh, here it is. Okay, this here. No, this is the plus operator. Is there a star?
It's at the very bottom.
It stays
Oh.
at the bottom last one.
Oh, okay.
There you go.
Okay, it's there. So, let's take a look at this star operator, multiplication. So the multiplication operator takes as a parameter a rational constant. We're calling it, formal parameter name is arg. And what we're going to do is we're going to create, what is this right here, rational temp?
Object.
So we're constructing a default local default rational. What's the value of temp right now on the next line? 0 over 1, because it's default constructed. Okay, then I'm going to say temp top. You understand what that means, right? The top of the temp is equal to top times arg top. You know what arg top is, right? It's the top of the parameter rational. And I'm multiplying it by top. What's top?
The actual top to the.
Okay, it's not 0 necessarily, but what it is, it's actually the top of the host. So let's see how that would work. So I'm going to write some code here. So let's say I have rational R, and I'm going to say, for example, 1, 3. Everybody understand what that's going to do, right? So I'm constructing a rational object using the intent constructor. Top is 1, 1 is going to be 3. Now, then I'm going to have rational, let's say I'm going to have S 2/3, comma, T. Okay, what's the value of S? 2/3, right? 2/3. What's the value of T? 0 over 1, default constructor. So now what I want to do is I want to say T is equal to R times S. Everybody immediately knows what that's doing. It says T is equal to R times S. Well, R is 1/3, T or S is 2/3. That's going to be 2/9. Right?
Yes.
Right. It is going to be 2/9. So, let's find out what the heck is going on here. So, as we look, see if I can raise it up a little bit. That's it. That's all I got. No way I'm going to be able to stop where I want it. All or nothing. Fine, we can see it. Right? Okay. So let's draw a little picture of what's going on here. So R is an object with 1/3 in its properties. S is another object with 2/3. And T is an object with 0 over 1, default constructor. Now we have this code. So, we've already learned how to parse code. And this is an especially easy parse. Because we have, this is an operator, right? And then this is going to go like this. And this is going to go like this. Are you with me? Okay, let's see what happens here. So the first thing that's going to happen is this star operator. Now it says, what type is this?
Rational.
It is?
Rational.
So we have a rational star rational. Now if we had int star int, C++ would say that's just my primitive operation, I know how to do that. But this is a star, and this is the host. So R is actually the host object. And S is the parameter object. So if you want to think of it, okay? So S is arg. So arg.top is equal to what?
Top
Is
of
equal to 2. Arg.top is equal to 2. Arg.bottom? 3. What's top?
1.
What's top?
1.
Top is 1. What's bottom?
3.
So top and bottom are referring specifically to if I said S times R, would the result be the same? Would the result be the same?
Yeah.
But what's the value of top now?
2.
And the bottom?
3.
And what's R dot top?
1.
Get the idea? Okay. So when we now what kind of operator is this? Binary, unary? It's a binary operator. Whenever we overload a binary operator, what follows the operator is the parameter, and what precedes the operator is the host. Okay? Now, let me tell you exactly what's going on in this code, because you're going to be surprised how much action is going on right here. The first thing you have is you have S times R, which means that R becomes the parameter called arg. And arg is right here. It's coming in by value. Because it's coming in by value, C++ automatically executes the assignment from R into arg using a copy constructor. So the copy constructor is actually acting on R. R is taken as a parameter into the copy constructor, and then arg is constructed by the copy constructor. Okay? So this comes in like this. Now here, we are executing a default constructor. Then we are doing some simple integer times integer equals integer, right? Again, same thing. Then we're saying return temp. When we return temp, we're returning a rational. Because we're returning it by value, we're doing a copy constructor. The copy constructor takes this object and copies it into the space of wherever is this code. So wherever this code is living, that's where the S times R temporary is copy constructed. You got me so far? The value is copied right here. That's where the copy constructor copies it. But then we have an assignment here, and the assignment operator has also been defined by us. So therefore, the assignment operator, which by the way I think I can see up here, what happens is, you see this guy right here, the return value from this expression? That's the input into arg. How does it get there? Copy constructor. How come it's copy constructor? How do you know it's copy constructor? Because it's not taken by reference. Anything not by reference is by copy constructor for objects. So I copy construct this thing into here. Okay? And then T becomes the what? Host. T is the host for this one. And so what happens is T is the host, therefore top and bottom refer specifically to top and bottom of T. So what I'm doing is I'm changing the top and the bottom of T. And then there's a return value from the assignment, but this method returns void. Right? So really, what happens is this thing is an expression killer. This kills the expression. So let's modify it, shall we? So, and we're going to modify in the following way. Rather than returning nothing, which is void, what could we return? I think we could return a rational, and here's why. Because if I wanted this code to look like simple code that people use all the time, I could have, for example, another rational called u, and I might want to say u is equal to this, so that this return value could be further assigned into here and returned. You follow what I'm saying? That would trigger a syntax error right now. Because our behavior for our assignment operator returns void, and a void cannot be assigned because a void has no R value. Right? So you cannot assign a void into something. So what we're going to do is we're going to modify this assignment operator. So we have to return something. Now what can we return? You see what I'm saying? What can we return? So what I'm telling you right now is we're going to attack this line right here. We're going to put a return statement here. But I can't reach that high because I don't want to write on the screen. So I'm going to write low. So what I want to do is I want to say return, and now I got to put something that's going to work. I can't say return top, that's an int. I can't say return bottom, that's an int. So what I really need to do is I need to return a rational. So listen very carefully what I'm going to say. I'm going to do it in the simplest possible way. Inside every object is a keyword which is a pointer to the object itself. So every method in a class has access to it. And this pointer is called this. You've heard of this, right? What is this? What is this? This is a pointer to the host. And every method has access to this. Let me qualify that. Every non-static method has access to this. Does that make any sense? You know what I mean by static? So and we haven't talked about static method, so forget about it for now. Every static method has access to this, including all non-static operators. FYI, we have not had any static methods, so relax, there's nothing to worry about right now. So what I can do is I can try to say return this, but that's going to cause an error, even though this is well known. Why is that an error? What is this? Not a reference. I never said the reference word. What is this? It's a pointer to the host. What type is the host? So what type is this? Rational?
Pointer.
Rational pointer, right? So I'm returning a rational pointer, but this says I should be returning what? What do we say we're going to return? We said we're returning a rational. So I can't return a rational pointer when I'm supposed to be returning rational. I'm crossing void, putting rational here. So I need to return a rational, not a pointer to it, because there are different types. So if I want to return the object that the pointer is pointing to, what do I need to do? Dereference it. So I should do what?
Star.
Dereference this. So I can return star this. Do I have to put parentheses around it? Only if you want to. Because basically this operator is very low priority. This is very high priority. So star, what type of star is this?
Rational.
That is a rational. And we're returning it how?
Rational.
When I cross void and I put rational, we're returning the host by By value, which means that the value here is going to be copy constructed into here, and then it's going to be assigned into here, making this the new host. Yeah, what's your name?
Ronaldo.
Ronaldo, go ahead.
So, do we always need to have a copy constructor?
Okay, so that's a great question. Yes and no. So if you don't code your copy constructor, you will get a copy constructor for free, which may not do what you want it to do. Okay, so you never have to code the copy constructor, but when you don't code the copy constructor, you get a default copy constructor that simply does assignments of the individual properties. If your object is connected to pointers, lists, and resources, like files, etc., 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 then basically you will have an object that is referencing two objects that reference the same thing. They will not truly be copied. And a default copy constructor gives you what, in effect, is a shallow copy. And a shallow copy is that if this object has some references, and I shallow copy it, then both these objects are referring to the same things, which means if I change from here to there, I've effectively changed from here to there as well. And that's typically not desirable. So, for the most part, for professional programming, you want to define your own copy constructor. The second question is, do you need to define your default constructors? Well, I think it makes a lot of sense to define a default constructor. Now, if you have a class, and that class has no constructors at all, none, then C++ will give you a default constructor. And that constructor will essentially do nothing. But it will allow you to default construct objects. As soon as you define any constructor other than the default constructor, it undefines the default constructor. So you cannot create an int constructor and expect the default constructor to still be there. Once you define an int constructor, a float constructor, any constructor, then the default constructor is undefined. And I guess the logic is if you care about constructing your object carefully with an int, then you probably should care about how to construct it with nothing, because, what do you expect me to do? I can't be too smart. Okay, so you can see that if you look at this code, if we change this from void to rational, you can see that lots of methods get executed, including this method is executed twice. We have the copy constructor, our own code, executed about 3 or 4 times. Okay, so lots of action going on here. Any questions about this? Now, how am I implementing this constructor? Well, clearly, all I'm doing here is I'm creating a temporary rational default value, and I'm assigning it the product of the tops, and I'm assigning the bottom of the temp the product of the bottoms, host parameter, returning it. Now, logically speaking, it's fine, but there's something I should do before I return temp. What I should call something on temp before here.
Normalize.
So the code should be what? Temp.normalize. Then you return it. Okay? Does that make sense? Right. But we are a method. So that's why we can call it. Okay? All right. So I think that example was a good one. I think there's a lot of... Right. So, yeah, Chris?
If you don't want a default constructor,
If you don't want a default constructor, then don't define it.
so go and analyze it.
Correct. So if you don't, so if you have, like, for example, let's say we just got rid of the default constructor from the header and from the implementation, but we had int constructor, int constructor, blah 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 constructor, copy constructor. Fine. That's fine. You don't have to allow default construction. Usually we like it because it allows people to safely construct things without having too much knowledge about what they need to do. But it is your decision. Now, let me show you one more thing that I wanted to show you before I actually move on here. Just so you understand. All right, so because operators are really methods, it's a little tricky if you look at this code here. If you look at it, it's a little tricky. You might not be aware of the fact that you are actually executing a method here. By the way, do I need any more parentheses or am I good? Semicolon, don't worry about it. It's just an expression. But this is more important, so that's going to happen first. Return value, assignment, return value. Now, the associativity of the equals operator, guess what? Right to left. That's why we can say things like this. Let's say we have a bunch of ints, we can say D is equal to C is equal to B is equal to A is equal to 3. Everybody gets a 3. So, associativity, right? Right to left. Okay, so let's even erase the U, we keep it simple. So I can rewrite this in a different way. I can say T is equal to S dot, because I'm invoking a method, right? Which happens to be an operator. Okay, so that's alternative syntax. Now it looks exactly like a method. So we are selecting from this rational object the method operator star with parameter r. This is exactly equivalent. Which one do you like better, top or bottom? How many people like top better? Okay. These are people who like to play it safe. I don't know what I'm doing. But logically, this looks very nice because it's very clean. It's very clean, this expression. And that's what we like about it, is that it's very clean and it looks just like simple code, and yet there's a lot behind it. There's so much going on here, but it looks clean. So as long as we define this properly and return a type compatible with this, we're good to go. Now, let's say we created a double primitive, double D, and I wrote D, oh, this is good. D is equal to S times R. Do you know what I'm trying to do?
Trying to convert it to decimal. Trying to convert it to decimal.
Okay, so what I'm trying to do is I'm trying to take these two rational values and I'm trying to assign them into a floating point primitive. Now, if I could do this at all, what would I have to do? But what would I have to do in terms of describe? What would I have to change in terms of my methods in the rational class? Would you agree? Would you agree that S is still a host, and star is still a member operator, and R is still a parameter? Okay, so the only thing I could do to make this different is what?
Do typecast, top and bottom, so those points and
Well, what I'm saying is I want it to work just like this.
Change the equal operator maybe to return a double.
Okay, so I could try to overload another operator to return a double. That would be very smart, very nice. So basically everything is the same here, but the return type here is rational, and here it's double. It's not going to work. And the reason it's not going to work is a very important reason, is that you cannot differentiate overloaded methods or operators only by the return type. You can have different return types from the same operator, but that cannot be the only difference. So for example, let's say I had S, which is irrational, and let's say I had another one here, E is equal to 3.8, and I said times E. Then, would you agree that this is still rational? This is still a member operator. This must be the parameter. What type is it?
No.
Is it different than this?
Yes.
Then it's an overload. So that could work. That could work. Now there are other things we can do to make that other previous model work, but the important thing to remember is that we cannot differentiate two overloaded operators. We can have multiple versions, but the only difference cannot be the return type. They may have different return types, but you have to vary either the number of parameters or the type of those parameters. That's it. This is the method for normalize. I'm not going to bother talking about it. Just tries to divide as quickly as possible by the common denominator. So it basically says GCD top and bottom is D, top slash equal D, bottom slash equal D, right? And this is the GCD. This is the tricky one. But, okay. So now the display method is, all it's doing is saying cout top slash bottom. Pretty simple. And then we have a method called copy. Notice that this copy, is this, now, what file is it in? It is in the CPP file, right? We didn't have it in header. What's the first parameter? Parameter is a rational pointer and another rational pointer and an int. And all we're doing here is we're looping for int I equals 0, I less than I plus plus. Star 2 plus plus equals star from plus plus. What operator is higher precedence, plus plus or star? Plus plus. So that means that star 2 plus plus first does 2 plus plus. What does that return? What is 2? It's a pointer to the first rational. So what does 2 plus plus return?
2 is 1, 8, 2.
Say it again. Hey, let me ask you a question. What do you think a pointer to a rational points to? That's a good question. All right. What do you think a pointer to a rational points to? Huh?
The address of the rational.
Louder.
The address.
Very safe answer. Very safe answer and correct. Points to the address of the rational. What do you think is at the address of the rational?
Boot value.
That's a very safe answer. I don't even know what it means. Anybody?
Class definition.
Huh?
Class definition.
Actually, it's the beginning of the data for that object. For example, so if you have properties int, it's going to be the address of the beginning of the first int. So, so 2++ returns 2, which is the pointer to the first data byte. And star, what do we need star? What does star do? It dereferences that int, and what type is that going to be for our rational?
Integer. Integer.
No,
And
it's not an integer. Yeah.
Yeah, so plus means return? Or is it?
Plus means post increment, which means it does nothing until we, the expression we can, you know what, I'm going to skip this method right now. Because this is too much right now. Okay. Don't worry about it. Okay. Now, we're going to look at the method read. Let's do something simple. So read, notice that this is not a method. This is a function. All right, go back to here. Read is a method. Returns nothing. So basically what happens is when you try to read a rational, it does a cin into top into bottom. So it basically goes in and reads an int, it converts an int, and it converts an int, and then it normalizes it. That's it, very, very simple. The last method is the operator output, and this one is the one that really looks the most complex, so it's really the one we should try to figure out what the heck is going on here. What is an O stream? So an O stream, when you write a code that looks like this, see out anything. So see out 3, for example. Can you all see that? See out 3. You see, you know what this thing is called again? An operator. So what is this thing? What say again? It's a host. Oh, yeah. Okay. So that's the host. What type is the host? Take a wild guess. It's an O stream. I don't know if that's what you said, but that's what it sounded like to me. So C out is an O stream. Now, did you notice that in a rational class, our overloaded output operator was not a member, it was outside of the class? We put it in there because it kind of wants to output rational things, but it's not a member of the class. Why not? Why not make it part of the class? Well, for example, what I really want to be able to do is, I have a rational object called R, I want to say C out, output R. Right? I mean, doesn't that make sense? Isn't that what I want? So what I decide to do is I decide to make it a member. Put it into the class as a member. So to do that, I would have to go into the header, and I will borrow a little bit from here, so I'm going to say, I'll explain that later, O stream, reference, operator, output. Now you understand, I'm trying to make it as, this is going to be a member, right? I'm going to try to make it as a member. So I'm returning this thing. It's an output operator. And as a parameter, it's going to have to take what? A rational. So somehow rational, so I'm going to just say rational. And I can't use, well, I can use R, but I'm going to use X for some reason. I'll use A. Okay, then I'm going to code it. Does anybody see a problem with this? Anybody see a big problem with this? Look at the declaration. Well, this is a declaration, so I don't know. I have to code it. Here's the declaration. Here's the use. They're not compatible. There's something wrong here. Anybody see it? Let's go back to our example. Remember this? Remember this expression? What's this?
Operator.
What's this?
Operator.
What's this? What's this?
Operator.
You see the problem? So that host is an O string. If you're going to make it a member, that host becomes rational. So what I have to do, I have to say O string reference, and I could write it like this. That would work. What is this? What's this? What's this? Okay. What's the problem with that? It doesn't look normal. I want to say C out R, not R. See it? What the heck is going on here? See what I'm saying? I want to be able to write C out R. And then I want to say also S. And then I want to say also high. See what I'm saying? That's what I want to be able to do. I want to just string this stuff out like that. So we got a problem. We can't do that. So what we do when we have a binary operator, like plus, like star, like the output operator, and you make it a member, the thing that goes before it is the host. The thing that goes after it is the parameter. So if you want it to look like this, you cannot make this operator a member of rational. You have to overload the operator outside of a class, and you basically declare it as an operator. If you declare an operator outside of a class, and it's a binary operator, like this one, or the star, okay, if you do that, then what happens, once you declare an operator outside of a class, there is no host. So that means the operator is here, and the parameter in front of it, and the parameter in back of it are both parameters in the definition of that overloaded operator. There is no host. So whatever comes before and after it for a binary operator, they both are parameters in the implementation. And that's what we have over here. So what we have here is we have an output operator overloaded outside of a class. It takes two parameters. The first one is an O stream, so cout can be first, and the next one is the rational, so it can follow. So this one followed by the operator, followed by the parameter. That's the way the syntax is going to go. Does that make sense? So now you can see what's going on. So now what we have here is this rational object. We simply say out. That's the stream. Remember, if I say cout becomes the parameter, and cout comes in, and it's called out locally, right? So, and this is important, so what happens is out is now a substitution for cout. Cout is an O stream, out is an O stream. Now, how is out coming in as a parameter? Value or reference? Reference, which means that out is just another name for cout. It's not a different object, it's the same object. Changing out changes cout and vice versa. This now, what I'm going to do is I'm going to out rational.numerator / rational.denominator, end line. And then I'm returning out. Why am I returning out? Because out is an O stream, and I'm supposed to return an O stream by reference. Now, imagine that I forgot to send in out by reference. And I did it by value. Then what would happen was, Cout is an object that's perfectly connected to output stream, and now I'm creating something called out, and I'm copying it. As I'm copying it, when I output some of this data here, I'm modifying out object. But I'm not modifying this one. Okay? Do you understand the different objects, right? This one is living in the function that called the operator, and this one is living in the operator space. We'll talk about specifically what that means, but they're different objects, suffice it to say. And once the function is over, this object is going to get garbaged out, because every local function declares its local stuff, and then it kills it off each time it starts as it enters and exits the function. So what happens is, if I forgot to send it in by reference, I would make a copy into A, and it would work until you had to return, because when you returned out, which is a copy by. So you would now be returning by reference an object which is just going to get garbage collected in about a second. Disaster. What if you sent this by value and you returned it by value? Then again, you have a copy of Cout in out. Out makes changes in its state as it outputs more stuff. It keeps track of how many bytes it's written, where it is in the stream. And then you're returning it. You're returning it. And now, think about it. Because this is just an operator, here's the value, and this value is an O string, right? So therefore, this O string is going to go into S, right? Which means it's going to go again into by value, return by value, and it's going to come out by value. It's going to come into here. It's going to invoke the O stream character pointer. We haven't talked about it too much. Character pointer operator. And then it will return. And everything will be nice. Except that once Cout went in as a copy parameter, and Cout has been modified each time through this process, the value that's returned here is not Cout, it's the new updated value of Cout, but it's in a different location, and it's going to get garbage collected, and Cout has no idea what has been going on. So when you use Cout again, Cout is going to think, Cout actually wrote all the way out here as out, but actually Cout still thinks it's over here. It didn't realize that any writing went on at all, because a copy was manipulated. So that's why it's important to take the stream as a reference and return the stream as a reference, so that you are only dealing with Cout, and A and out becomes a reference to the same object. When we return it, we return the reference to the same object, and it goes into the next one. It just refeeds it into here and returns again the same object, and refeeds it into here and returns it as the same object. So we're always modifying the same object. That's why it's important. Okay, done.